I think today the link between environment and health is becoming ever more obvious. We've heard this morning, I think, from Mariana, who said it's all about how we want to live together on this planet when she was talking about plastics in the sea. And somebody also said it's how the world around us affects our bodies. And I think Joanna also mentioned, are we ready to prepare for the next health emergency now? And here's an emergency that we know is happening. And my question today is, are we really committed to doing something about this? So first of all, I've got a few numbers for you. So I'm hoping we can advance through the slides. There we go. First of all, 20 of the hottest years on record have occurred in the last 22 years. And the next number is 8%. 8% of the world's species are currently in danger. And we don't know whether one of these species that we might lose is a species that could help prevent the next health pandemic. What we also know is the next figure of carbon emissions. The UK currently emits 375 million tonnes of carbon, and that might not mean a lot to a lot of people, but the best number there is zero. However much we emit today has to go down to zero if we want our planet to keep supporting us and allow us as humans to live on our planet. The next number really is about what we've got to do to get there. At ISG, we've been doing some research on sustainable buildings and where we currently are in terms of energy consumption and where we need to get to. And it's very simple. In a future world, all energy has to come from renewables. And we won't be able to use as much energy as we do today. In fact, we need to go down to about 80%. So we only use 20% of the current energy. And for the healthcare sector, we currently know from our research at ISG that the health sector is the third largest consumer of energy per metre squared, which means we've got to go down from 617 to about 100. And that figure we are still trying to work out today. And what's all this going to cost? If we look at the current consumption and what it will cost to get buildings down to net zero, we're looking at about £100 billion for the healthcare sector alone. Now, my question is, where is that money going to come from? It's a massive amount of money, and we haven't got very long to actually find it. So moving on to the next slide, I've got a little bit more good news for you. The good news is, as we click around this slide, that we actually know how to get buildings to net zero. It's actually quite easy. I know how to do it for the last 20, 30 years of my career. When I started out after a physics and engineering degree, I really felt that this is where I wanted to focus my efforts because it was so obvious that we needed to do it. The first key is obviously collaboration. The way we get buildings to net zero is that everybody in the construction industry works together. We make sure that we only design things once and we share data, as we've heard before. It's all about openness of data and actually making sure it's consistent throughout the process. And obviously next we'll go on to how we actually structure the buildings. We'll no doubt need a platform which will help us design for manufacturing and assembly. And this is where technology starts to come in. It's all about manufacturing off-site, ready for putting together. But while we're doing this, let's not forget the D at the end of manufacturing and assembly is for disassembly. This is about making sure the materials we use to build buildings today, we can disassemble when they're not needed anymore and then use them for other buildings. Particularly in the health sector where we don't know what the future of the estate will look like. Will it be more distributed in the future? Will large hospitals be split up more around the community? So we can be very nimble with buildings that we've assembled in a way to disassemble, and it saves the Earth's resources. The technology is also there to allow us to manage buildings very sustainably. We know from a model what the building is meant to consume energy-wise, water-wise, what the air quality should be. So we can use technology to monitor if this is happening in practice and raise alarms so that automatically we manage the building in a very environmentally friendly way. And it is about life cycle. We have to consider the whole life of that building and what it's going to do to the planet over its life cycle, not just its capital cost. And finally, on this slide, it's about getting the contracts right to enable all this to happen. At the moment, the way the construction industry works is it's very siloed. Everybody has their own contract and everybody tries to make sure they don't get caught out in the process. What we need to work together in the future is to collaborate so that the contracts are actually about a building that performs for the occupants within the building. And so moving on to the next slide, I just want to also mention that it's not just about getting to net zero carbon. As we click through this slide, yes, we've got to get the fabric up to a quality which will allow us to use minimum energy. We've also got to use, as you'll see next, lots of renewables. And there are renewables that aren't developed yet. There will be fuel cells coming through which are hydrogen driven, which will power our buildings. And all this needs to be flexible so that the buildings we build today can adapt to these new technologies. But we sort of know what they are and we can sort of get there. From scientifically, it's not that difficult. And as we click through in the cloud, we know we're going to have smart metering. We'll all be linked to very smart grids. And when we've got these grids, in buildings of the future, we might have alerts on our phone when the building is using too much carbon. And then we have to go and do something about it. And the FM team will be told exactly where to go on the model, how to make these adjustments, and how to really maximize the efficiency of the building. We can also have health alerts as well. There's a standard called the well-being standard, which isn't used so much in the health sector, strangely enough, but it's all about making an environment that's healthy for the occupants. And we can actually create alerts. So when the air quality is too bad outside or not good enough in the building, or there's not enough daylight for the people in the building, we can raise alerts to FM teams and building operators to make it better. And especially for patients recovering, they need to have the best environment possible to allow their bodies to recover. And it's not just about health and carbon. There are a number of other things to consider in what we're calling a smart city of the future. As I've mentioned, circular economy. Can we build buildings that can be dismantled? Because raw materials have a lot of embodied carbon, as it's called, the energy that's been used to make this. And in the future, one of my predictions is that steel will become as expensive as diamonds. And we won't be able to build buildings out of steel and new concrete. We also have to think of social value. We have to go through and think about other kind of things as we click through the slide, including the resilience of our buildings. So as our buildings go through time and it gets warmer, we have to make sure that these can resist this kind of increase in heat. As we click through there as well, we've also got to make sure that we use minimum water. Water will be the new carbon and there will be wars over it. And last but not least, we have to think about nature-based solutions. We've been calling it biodiversity and maximising the biodiversity on the planet. We have to try and work out how we can make a new building as efficient in its ecosystem as a forest does. And if you think of a forest, it's really, really efficient on rainwater. It recycles things, it doesn't waste things. And it's all about getting this balance right between humans and the planet if we want to survive on this planet. The real challenge that is coming through beyond the environmental standards we use at the moment, which are called BREEAM and LEED for those out there that are into this kind of thing, is can we set a standard that makes the new building operate as efficiently as a forest just down the road? And there are quite a few large high-tech companies looking at this now, which is really interesting, how we catch water, how we reuse water. So moving through this last one slide, here's a picture of a building which was designed in view of nature. And my challenge really is everybody ready to play their part to try and develop these buildings which will allow us to survive on this planet? Here are a few more numbers. You might think the initial number of 100 billion was a lot of money for us to find just for the healthcare estate alone in the UK. But what's the cost of doing nothing when we don't have enough water left on the planet? What are we going to do about it? So for the existing commercial building stock that we've measured during our research at ISG, if we were to apply very tight energy efficiency standards to that across the whole estate, and maybe not all of it needs just quite as much upgrading, but we're looking in the order of £2.5 trillion in the next 30 years maximum. That's something like 800 billion a year. Where is it coming from? And that's why I say, are we ready to play our part? Are we really serious about doing this? Or are we just making commitments that nobody knows how to actually fulfill? We need to get the priorities right. Where do we start? Where do we go next? And in what sequence do we do things? But we do need to start soon. As our last slide shows, the research we've been doing is showing where our buildings currently are on this energy efficiency challenge, so that all buildings in the future will be able to use renewable energy and will be able to call ourselves net zero. And that means when we're only using renewable, there's no option to offset energy. There's no option to say, I'm going to use a gas boiler and I'll buy offsets, because there are no offsets. We're at a zero carbon world. So I'm going to leave you with two final figures. Here's my challenge. Are we really serious? And if we are, where's it coming from? And we have 10,000 days roughly and counting to 2050. So what's everybody on this conference going to do tomorrow to help us get ready for what we know is going to be another major health emergency? We're going to have migration of populations where there's not enough water to drink, and wars will be fought over it. So I'd just like to leave you with those thoughts, and I really hope that we're up for this challenge. Thank you.